In this problem, we're given the specifications for the B field of an electromagnetic wave, and we're asked to write down a complete expression for the E field of that wave. One of the first things that we're going to need to do is to calculate the value of the wave number k. There's a couple of different ways that we can do this. One is we can just start with a relationship that omega over k is equal to c. This is one of the relationships that we derived in lecture. If I didn't happen to remember that though, I could use the fact that we know that the speed of light c is equal to the wavelength times the frequency. We also know that k is equal to 2 pi over lambda. So what we can do in that case is then we can write this as 2 pi times f over c. And we can calculate the k from this. Now 2 pi f happens to be omega, and so once again we get the fact that k is equal to omega over c. So let's go ahead and just put in the numbers and solve for this. K in this case then, omega is given 3.6 times 10 to the 15 radians per second over c is 3 times 10 to the 8 meters per second. If I perform that calculation, I get the k is 1.20 times 10 to the 7, 10 to the 7 inverse meters. So this is a start. We now know k. Next thing we're going to do is figure out what the E field amplitude is. Now know that there's a relationship between the E field amplitude, the magnetic field amplitude, namely that E is equal to CB. So if I just write down the speed of light, 3 times 10 to the 8 meters per second, times the amplitude of the B field, 45 times 10 to the minus 6 Tesla, which is a Newton second per Coulomb meter. And I multiply these things together, I can calculate the E field. That turns out to be 13,500 newtons per Coulomb. I have almost everything I need. The last thing I need is the direction of the E field. I know that there's a relationship between the direction of the E field, the direction of the B field, and the propagation direction. Okay, I know that the B field is pointing in the X direction, the I hat direction. The propagation direction is in the Z direction. I can write that as Z hat. And so I have to figure out that Z hat cross what is equal to I hat. And a little bit of work with the right hand rule shows that E hat has to be pointing in the minus Y hat direction. So I combine these things to write down the an expression for the E field. The E field is minus 13,500 newtons per Coulomb in the Y hat, or I can write that as J hat direction, times the cosine, 1.2 times 10 to the 7 inverse meters times Z minus the angular frequency, 3.60, times 10 to the 15 radians per second times the time.